Today we're going to talk about some things that you already know how to do, or you should remember how to do them. So I'll just remind you just in case you've forgotten. Is that fair? And then we're going to add a couple more things that are new to Algebra 2. Okay? So things that you should know how to do are something like this. Square root of 2 times the square root of 10. How do you do that? Nope, no calculator. Remember, you're not button pushers. You're thinkers. Do you know 2 times 10? Do you remember that rule? Now, if that's what you put on your quiz or your test as your answer, you'll get partial credit because you remembered the first part of the rule. But it's not all the way simplified, right? Because I can do this, because I can go from here to here, does it make sense that I could also take it down into parts again? But I don't want to take it to 2 and 10 because I don't know the square root of 2 and I don't know the square root of 10. Are there any factors of 20 that you know that you do know the square root of? What's the factor that you know the square root of? 4, right? You know 4, and 4 times what equals 20? 5. Well, what's the factor? What's the square root of 4? 2. What's the square root of 5? I don't know either. Done. Do you remember doing that? Good. So another thing that you need to have remembered how to do is something like this. Square root of 30 divided by the square root of 10. Square root of 3. Can we break it into its parts to simplify it? That's it, right? Because what are the factors of 3? 1 and 3. Well, that doesn't help me at all because I could break it into 1 and 3, and I know the square root of 1 is 1, but I still have the square root of 3. It's still the same thing, right? Okay. So those are things you know how to do, correct? What about this? How is that different? What, the little baby 3? That's what's different? Is that how we're going to talk about this? If we were 7, that's how we would talk about that. Oh, the little baby 3. Okay? It's not how it is a cube root, isn't it? Okay? Well, if this is a square root, why doesn't it have it a little baby 2? It actually does, doesn't it? Okay? It's called a square root, so I know there's a little baby 2 there, but I don't write it because it's like understood. Right? Just because, like, if I just write the variable x, what's the coefficient on this x? Well, why don't I write it? It's understood. I know it's there. What's the exponent on this x? 1, why don't I write it? It's understood. I know it's there. I don't have to write it. Okay? Is there a little baby 2 right here? Yes. Okay? Guys, this symbol is actually called a radical. That's what the symbol is called. We most often use it as a square root, so we usually just call it a square root sign, right? It's actually called a radical. Its really mathematical name is called a radical. Okay? But that's why sometimes people get confused when there's this quote-unquote little baby 3. Okay, we're going to be okay with calling it a cube root? Okay, so what do I do in this case? What do I do in this problem? Doesn't it just follow the same rules as this one? So what do I get? Cube root of 42. Now, can I go any further? Well, here's the deal. If I'm thinking of numbers that I know the root of, or the square root of for 20, 4 is pretty easy to find, right? But I could have gone 2 times 10 and 2 times 5. And if I'm looking for a square root, I've got to find 2 of those values, right? What do I do for a cube root? I'm trying to find 3 of them, right? So I could go 2 and 21 and 3 and 7. Are there 3 of any of these factors? So guess what that is? It's the answer, right? That's the simplest that we can go. That right there is just the answer. Okay? What about the fourth root of 8 times the fourth root of 2? What do I do? Same thing as before, right? So I get the fourth root of what? 16. Can I go any further? Well, this is 2 and 8. This is 2 and 4. This is 2 and 2. What am I looking for? I need 4 of them. Do I have 4 of them? So this equals 2. Is that the only way to do that? Can I show you another way? Do you know how to take the fourth root of something in your calculator? Can I show you? Look right there. See the nth root? It's asking for the nth root. Justin, please don't do that. If I press Control and then that button, here's what it pulls up. And I actually can put in the fourth root of 16. 2. Now, what if I try to do the fourth root of 15? Is that what I want if I give you the question, fourth root of 15? I do not want the decimal. I do not want you to be button pushers. I want you to know how to enter things in the calculator, but I don't want this as an answer because that's showing me you know how to be a button pusher and not a thinker. If you get this as an answer, I need to see a factor tree and see what's going on. Does that make sense? Okay. Any questions so far? So you just want to go right to a hard one? All right, right to a hard one. You ready? This is harder than any homework problem you will have tonight. Just making you aware of that. Okay? I'm going to go slow so we can make sure that we're following all the steps. What do you want to do first? So we should just multiply like it asks us to? Okay, so this gives me the cube root of 54 over the sixth root of 4. So what should my thought process be right now? So you're thinking about 54 first? Okay, so cube roots are hard for me to remember. I remember some of them, but not all of them. Okay, so should we try a factor tree here on 54? So 2 and 27. 3 and 9. 3 and 3. So I've got 1, 2, 3. I've got 3 threes, right? So what's that going to turn out to be here? 3 cube root of 2. I know that the 3 has a cube root, so I pull that out in front. What's left that I don't have a cube root for is 2. That stays inside. Okay? Can I do anything to this? No, do I need to do a factor tree of 4 to know that there's not 6 of somethings in 4? No, we can be smart enough for that, right? So 6th root of 4. So this is not the answer. Okay? It's not completely simplified. But at first you're thinking, you can't do anything else. Well, if you will think back for a moment to yesterday. And specifically on this page right here, right, we said 16 raised to the 1/2 power is the same as the square root, because in our notes, we said the numerator is the power and the denominator is the root, right? So can I rewrite this problem a little bit? Just for the record, the answer is yes. Okay. So the numerator is going to be 3 times